Equation of lines in standard form. Question 13. A line passed through the points 3, 2 and 0, 5. Determine another point on this line. So to find the equation of line, we can find slope first. We are already given the y-intercept, right? Since the y-intercept is given, I will not write the equation in standard form. I will write in slope-intercept form, okay? We can always convert it to standard form. Now the points are, let's say points are 3, 2, and let's call this point as Q as 0 and 5. Now the slope will be y2 minus y1 over x2 minus x1. Now y2 is 5 minus 2 divided by 0 minus 3. Now 5 minus 2 is 3 divided by minus 3. We get minus 1. So the slope is minus 1. So let me write the equation in slope-intercept form, which is y equals to mx plus b, right? And here we know slope m is equals to minus 1 and y-intercept is 5, correct? If I write 0 here and 5 here, I get y equals to b equals to y value 5, right? So that is the y-intercept. And therefore, we can write this equation as y equals to minus of x minus 1 plus 5, correct? To write it in standard form, we'll bring all the terms together and we'll write x plus y minus 5 equals to 0. So that gives us equation in this standard form, correct? So since the y-intercept was given, I use slope-intercept form to get the equation, right? Now, we need to determine another point on this line. So to find another point, what we can do is, we can just plug in different values of x and y, correct? So we can make a table, right? So let's make a table here, and let's say these are the values of x, we can find the value of y. Again, to find the value of y, slope-intercept form is better. So y equals to minus x plus 5, correct? So let me write down some values of x, right? We already know 0. Let's find what is the value when x is 1 or 2, right? So we can plug in x as 0. When I plug in x as 0, minus 0 plus 5 give me 5. So that is the first value, which is q. Let me write 1 now. Minus 1 plus 5 will give me 4, right? So this is another point on the same line. I can plug in 2. So if I plug in 2, minus 2 plus 5, I get 3. So these are different points, and therefore my answer is I could write point 1, 4 or even 2, 3. So like this, I can get many more points on this line, correct? Another important thing is, since we know the slope is minus 1, that means if we go rise by 1, run is minus 1. That means increase one value, decrease the other value, right? So by using that concept, we can find more points. If I increase 2 by 1, it becomes 3, and then I can decrease this by 1, it becomes 2. So that could be a value. Let me check. If I put 3 here, what do I get? Minus 3 plus 5 is 2. Do you see that? So it works. Do you see that? What I'm trying to say is, since the slope is minus 1, you can think the slope is like this: 1 over minus 1 or minus 1 over 1, right? That means increase y, decrease 1 by increase y by 1, decrease x by 1, or decrease y by 1 and increase x by 1 to get more points. Do you see that? So we'll follow this principle. We need not use the equation from a point to get more points using slope. This is another beautiful method which I want to share with you. I'm increasing y with 1, decreasing x by 1. So if I decrease x by 1, I get 1 here. Increase y by 1, I get 4, correct? So I get this value. Do you see that? Do you see that? I can get from here, if I decrease this by 1, it becomes 0. Increase that by 1. Do you see? This point is already there on the curve. So we get points after points by using this policy, right? So slope can also be used along with a point to find more points. We need not always find the equation of the line to get more points. So I'll explore this in another example. Thank you, and I hope you appreciate alternate method also.